Welcome back to the Deep Dive. Today, we are undertaking a pretty critical mission, I think. We're trying to understand the technology that isn't just, changing business.
Yeah.
It's accelerating it exponentially,
Well,
artificial intelligence.
right.
And we're going to move beyond the hype, really focus on the cold, hard mechanics of how it's being adopted.
And it's no exaggeration to say this is the new competitive battleground. I mean, we're not here to talk about chatbots rating, basic emails. We're looking at the foundational shift.
Oh, yeah.
The move toward custom, tailored AI solutions and, crucially, how they are generating concrete, quantifiable return on investment.
Exactly.
The question for every business leader isn't, should we use AI anymore? It's how do we customize it to our unique DNA?
That's the core of it. That is our mission today. We're going to distill the key insights from, a substantial stack of sources. Everything from global growth forecasts, real-world success stories, to some of the hard truths about the barriers to adoption. And most importantly, we need to map out this rapidly widening gulf again, what our sources are calling the AI divide.
The divide, yes.
This gap that separates the companies generating massive strategic value from those still kind of stuck in the pilot phase. We need to figure out what separates the winners, who are expecting something like 60% higher revenue growth, from the laggards.
And if you really want to understand that difference, we have to start with the key technological leap that's driving all of this innovation, and that is agentic AI.
Okay, let's unpack agentic AI, because I think most people are familiar now with generative AI, Gen AI, the large language models that generate content when we prompt them.
Right.
Agentic AI. That sounds like it's graduated from being just a tool to being more of an actor.
That is precisely the right way to think about it.
Yeah.
I mean, generative AI is fantastic, but it is fundamentally reactive. You give it a prompt, a specific instruction, and it generates a response.
You ask, it answers.
Exactly. It's great for creation, but it requires constant human oversight, prompting for every single step. Agentic AI, on the other hand, is built for autonomy.
Autonomy is a heavy word in tech. What does that actually look like in practice? Especially compared to the models we've all been using for the last few years.
Well, it means these systems can get a high-level goal, and then they figure it out. They figure out the necessary steps, the right sequence, what tools they need to interact with, and they do all the planning to complete a really complex task with minimal instruction.
They're learning.
They're learning from past failures and successes. They refine their own plan, and they take autonomous actions across multiple, often completely separate systems.
Okay, so it's not just draft an email for me. It's more like manage this whole workflow.
Exactly.
So let's use a complicated business process as an example. If a human just tells an agentic AI system, okay, launch the new product campaign in the APAC region, what happens next? What does the agent do?
See, it doesn't wait for the next prompt. That's the key. It initiates a whole complex sequence. So it might draft the campaign copy using, a Gen AI model.
Oh, yeah, the creative part.
But then it autonomously queries the inventory system for stock levels. It checks the legal database for regional compliance rules. It orchestrates the payment gateway setup, handles fraud checks in real time by integrating with external services.
Wow.
And then it triggers the logistics system for pre-shipping label generation. All of that happens through its own planning and execution against a set goal, not just reacting to one instruction at a time.
That is a staggering amplification of what one person can do. If these agents can automate planning and execution across all those different silos, well, it leads directly to that concept you introduced.
Super agency.
Super agency.
Yes. Super agency is the, let's call it the theoretical and increasingly practical endpoint of this shift. It suggests that individuals, when they're empowered by these highly autonomous AI agents, can dramatically amplify their own creativity, their productivity, and, their overall positive impact.
Yeah. So it turns a single knowledge worker into something like a highly leveraged enterprise.
That's a great way to put it. Suddenly they're capable of managing projects that would have required a huge centralized team just a few years ago.
The agent acts as the conductor of the orchestra, basically. It allows the human to focus on strategy and the big picture rather than managing every single instrument. That sets the stage perfectly for our first major focus area. If this power is available, the only way to really harness it successfully is through customization. So if agentic AI is the future, then it seems like customization is the engine that's driving all the success today.
Absolutely.
Our sources were incredibly clear on this. Generic, off-the-shelf tools, they're useful for basic tasks, but they just fall short when it comes to delivering that substantial strategic ROI.
They do. The defining factor, really, for the companies achieving massive gains versus just small improvements, it's the degree to which they tailor the AI.
And what does tailor mean here?
It means training the model, or maybe fine-tuning its architecture, specifically on the unique data, the processes, the proprietary knowledge of that one business. It's about embedding the company's unique DNA directly into the AI solution.
And this transformation, it's delivering measurable results across every major sector we looked at.
Yeah.
Finance, manufacturing, logistics, healthcare.
Everywhere.
And these aren't just, conceptual efficiency gains. They are hard numbers on a balance sheet.
And we really have to emphasize that this customization is not about wholesale replacement of people. The success stories consistently highlighted the importance of the human in the loop, or HITL, combination.
That winning strategy. The one that merges automation with human oversight.
Exactly. The automation gives you scale and speed, but the human expertise provides the necessary oversight, the contextual intuition, and often, most critically, the ethical calibration.
Right.
So in sensitive areas like diagnostics or finance, the custom AI delivers the rapid, high-precision analysis, but a human expert reviews it, validates it, and takes responsibility for the final decision.
Can you elaborate on that? What does that human-AI interaction actually look like in a high-stakes environment?
Well, in healthcare, for example, we see customized AI analyzing incredibly complex radiological scans and patient history.
A task that is mentally exhausting and really time-consuming for a doctor.
Incredibly. So the AI flags potential anomalies, it identifies high-risk cases, and it provides a preliminary confidence score. But the physician, using their years of training, reviews that specific output, considers the human context, and then makes the final diagnostic call.
So the AI doesn't diagnose?
No,
Great.
It augments the doctor's ability to diagnose faster and with fewer errors.
Okay, and what about in, say, HR? An AI might sift through thousands of applications, right?
And it provides a prioritized list of candidates based on required hard skills and experience. But then the HR team steps in to calibrate those suggestions based on soft skills, cultural fit, interview performance, all those qualities that are just inherently difficult to capture in purely quantitative data.
That interaction ensures trust. And I guess without trust, adoption just stalls.
Completely. Now let's get into the specifics of these results, because the numbers are really compelling.
Let's start with manufacturing. A sector that operates on razor-thin margins and where downtime is, literally catastrophic. The focus here was predictive maintenance.
Right. And traditional maintenance schedules are often just calendar-based, or they're reactive. You fix it when it breaks, or you swap a part out way too early.
Wasting money.
Exactly. They struggle to incorporate all the nuanced proprietary data that really indicates a failure is coming. And the costs of an unexpected failure can be millions in immediate repairs and wasted materials, not to mention long-term reputational damage.
Okay, so a custom AI solution had to overcome those limitations and truly anticipate the moment of failure. What kind of data was it chewing on?
It was a very dense data stream. The custom AI was processing real-time sensor readings, vibration analysis, heat mapping, oil pressure fluctuations, acoustic signatures from equipment all across the factory floor.
But the customization part, that came from layering on other data.
Yes, it layered that with historical machine logs, environmental data like ambient temperature and humidity, and the proprietary workload patterns specific to that plant's product mix.
Meaning the AI learned what normal wear looked like only for that specific manufacturer's proprietary process.
Exactly. It learned the unique, subtle patterns that signal an impending breakdown that a human or a generic monitoring system would just miss. For example, it might find that a specific combination of heat, vibration increase, and a certain workload peak over 48 hours is a 95% predictor of failure within the next 72 hours.
Something they didn't know before.
Something previously unknown.
And the ROI from this proactive approach.
A verifiable 40% reduction in unplanned downtime.
Wow.
And to put that in perspective, if a large plant averages, say, $5 million in losses annually from unplanned downtime, a 40% reduction is $2 million back on the balance sheet.
And that's not even counting the improved safety and supply chain benefits.
It's a direct material cost center impact. That is the definition of transformative.
It really is.
Yeah.
Okay, shifting gears to healthcare, where the precision of diagnostics is just paramount. The challenge here was enhancing the speed and accuracy of reading complex scans.
Yeah, the problem in many large health systems is fragmentation. Physicians are overwhelmed, diagnostic systems are often siloed, making it hard to compile a complete, accurate patient profile quickly.
So the solution needed a custom AI that could seamlessly integrate with existing electronic health records, or EHRs.
Right, which, for you listening, that's the centralized digital repository for a patient's entire medical history, lab results, imaging data, all of it.
Integrating AI into something that complex and that regulated, that must have been the key customization hurdle.
It was. It wasn't about building a new system from scratch, but about building an agent that understood the often messy, unstructured data inside the existing platform. So the customized model analyzed radiological images, X-rays, CTs, MRIs, looking for specific, subtle biomarkers for diseases like pneumonia, certain cancer nodules, or early indicators of diabetic complications, and it was tailored to the known patient demographics of that health network.
And the staggering result was a 28% reduction in diagnostic errors.
A truly profound number, because that translates directly to better patient outcomes. I mean, think about the speed of triage in an emergency room.
Right.
Quicker, more accurate readings allow doctors to prioritize treatment much more effectively. This improves safety, it reduces liability for the hospital, and it vastly improves patient satisfaction.
Right.
But again, for this to work at all, the solution had to be built with full data compliance and interoperability as non-negotiable.
Okay, now let's look at the customer-facing side, e-commerce and retail, where the goal is maximizing the value of every single click.
And the standard problem there is generic personalization. Big box stores might use a simple customers who bought X also bought Y logic.
Which we've all seen.
Right. But for niche or competitive e-commerce, that leads to high cart abandonment because the recommendations just feel irrelevant.
So the bespoke AI had to be surgically precise in understanding what an individual consumer actually wants.
Precisely. This bespoke AI was customized not just on purchase history, but on dynamic, real-time behavioral data. How long a user hovered over a product, what they put in the cart and then removed, specific search queries, and even external data points like their preferred delivery windows.
And the AI would generate personalized product bundles and content for that user, even changing it during a single session.
Yes, dynamically.
That level of predictive micro-targeting is the definition of customization. What was the financial impact?
The results were immediate and they were massive. A 35% boost in average cart value.
35%.
All due to highly relevant cross-selling and upselling suggestions presented at just the right moment, and an even more impressive 60% increase in email conversion rates when using these personalized product highlights in their marketing.
It really validates the idea that the one-size-fits-all AI model just isn't competitive anymore.
Not for customer engagement, no.
Okay, moving to financial services. A sector where automation has to be balanced against really stringent risk and regulatory requirements. We saw gains in two specific areas: processing speed and risk mitigation.
On the processing side, claims automation and insurance. It used to be this massive manual bottleneck, just reading, validating, and cross-referencing vast numbers of scanned, unstructured documents.
A huge time sink.
A huge time sink. So a custom AI was deployed to interpret these documents, extract key data points, validate the claims against policy rules, and instantly flag anomalies that might indicate fraud.
And that resulted in claims processed 50% faster and an 85% reduction in manual data entry.
That's the kind of efficiency that lets employees focus entirely on the complex, nuanced cases that really need human judgment.
But the real strategic customization came in risk assessment.
It did. We analyzed the case of a regional bank. Their traditional credit models were just too generalized. They couldn't dynamically adjust to transaction histories or local economic indicators specific to their region.
So their generic model treated a borrower in one state exactly the same as a borrower in another, even with different economic conditions.
Correct. So the customized AI model was built specifically around that bank's unique risk policies and its regional market data. It evaluated applicant behavior, their spending velocity, their historical transaction stability, and it combined that with standard credit bureau data and then overlaid macroeconomic indicators for that specific region.
So it allowed for hyper-granular risk scoring right at the point of application.
Exactly. And that specificity, baked into their underwriting process, had a stunning impact. They reduced their loan default rate by 19%.
19%. That's a direct, substantial improvement to the bank's capital cushion and its overall financial health.
It streamlined the underwriting process while simultaneously de-risking the entire loan portfolio. A perfect example of customized AI driving strategic, not just tactical, advantage.
Okay, finally, logistics. A system defined by physical movement and the constant need for real-time optimization.
Yeah, logistics companies, especially last-mile delivery, they struggle intensely with fluctuating variables. Static routing software, even basic GPS, just can't handle dynamic factors. A sudden traffic jam, a road closure from weather, or federally mandated driver rest periods that change the whole delivery window.
So a custom AI solution had to be an active real-time planner, not just a static map reader.
Precisely. This system was designed to continuously ingest live traffic conditions, detailed historical route performance, driver scheduling, and regulatory compliance. It dynamically rerouted vehicles in real time.
So if a major accident blocked a highway,
The agent would instantly calculate the fastest alternative routes for all vehicles in the affected zone, optimizing for speed while minimizing fuel burn and making sure drivers hit their rest windows.
and the outcome was measurable in fuel efficiency and delivery speed.
An 18% reduction in fuel consumption, which is massive for large fleets, and a 24% acceleration in delivery times. This doesn't just save money, it enhances customer satisfaction and operational throughput.
The cumulative evidence from these 5 sectors is just undeniable, isn't it?
It really is. Customization, powered by proprietary data and guided by a human-in-the-loop strategy, is the only path to major strategic advantage right now. Now that we've established that enormous potential, let's pull back and look at the market context. Because these individual successes, they're driving a staggering rate of adoption globally.
The market momentum is undeniable. I mean, looking at the 2025 data, we are far past the exploratory phase. The question isn't whether companies are looking at AI, but how deep they're wading in.
Right. The sources show nearly 4 in 5 organizations, a remarkable 77%, are now engaging with AI in some substantive form.
And how does that break down?
Well, that engagement breaks down into 35% who have fully deployed solutions across their workflows and another 42% who are actively running pilots. That level of penetration in such a short time is just unprecedented.
And the individual user growth reflects this. Daily AI users have nearly tripled in just 5 years, jumping from 116 million in 2020 to 314 million in 2024.
That's a steeper adoption curve than even the internet had in its early days.
Wow.
And specifically, generative AI adoption has more than doubled in a single year, climbing from 33% of organizations in 2023 to 71% in 2024.
And all of this is fueling a huge economic
A
engine.
massive one. The global AI market is projected to reach $1.01 trillion by 2031.
$1 trillion.
A trillion, with the U.S. market projected to hit almost $74 billion in 2025 alone, cementing its position as the largest market.
But here is the statistical insight that should really keep business leaders awake at night.
The competitive gap.
The competitive gap. The top adopters are expecting 60% higher revenue growth and 50% greater cost reductions by 2027 than their peers.
That disparity means that simply piloting AI is no longer good enough. Full deployment is now the prerequisite for competitive survival.
And to move from just piloting to full strategic deployment, we have to revisit that key concept we introduced earlier.
The shift to agentic AI and the concept of superagency, this is the difference between simply using a tool and actually transforming the entire organizational structure.
Right. We define superagency as the state where individuals can amplify their impact. Can you give a clearer picture of how this technological leap enables one person to operate at the scale of an enterprise?
Okay, think about a fractional CMO, a chief marketing officer who serves multiple small businesses.
Right, a consultant.
Exactly. Before agentic AI, they were limited by their personal capacity to write copy, manage ad spend, and analyze engagement. With agentic AI, that same individual can deploy a team of autonomous agents.
A team of software agents.
Yes. So one agent manages the budget across 5 different ad platforms. Another agent, trained on the client's specific brand guidelines, orchestrates content creation and scheduling across 6 social media platforms. And a third agent synthesizes all the real-time performance data and proactively flags necessary strategic pivots to the human CMO.
So the human CMO is no longer managing spreadsheets or scheduling posts. They're managing the strategy of 5 different enterprises at the same time.
Exactly. They are leveraging superagency to outsource all the operational complexity to the agents. The human is focused solely on high-value strategic decision-making and creative direction, while the agents handle the tedious, complex, cross-platform execution.
And this scale shift is enabled by some pretty profound technological innovation.
It is.
Let's delve into those. Starting with enhanced reasoning capabilities. How are models moving beyond just pattern recognition?
So the key here is the ability to engage in logical thinking, step-by-step planning, and nuanced analysis. It's often referred to as chain-of-thought reasoning. Previously, models were excellent at just identifying patterns in massive datasets. Now they're being trained not just on the data, but on the logic of how to solve problems.
And we can actually measure this leap in cognitive ability through standardized tests, can't we?
It's a very compelling benchmark. We see models like GPT-4 performing so well on complex human-centric exams like the Uniform Bar Examination that they rank in the top 10% of test takers.
The top 10%.
Which means today's models are approaching the cognitive intelligence level of someone with an advanced professional degree. This move from just pattern matching to demonstrable reasoning is foundational for agentic AI's planning capabilities.
Okay, the second major driver you mentioned is multimodality, moving beyond simple text.
Multimodality means AI systems can process and generate diverse data types, text, audio, video, imagery, all at the same time and contextually. This is critical for real-world application. For example, in a customer service scenario, the AI isn't just reading a transcript.
It's listening.
It's analyzing the customer's tone of voice, it's processing the image of the damaged product they just uploaded, and it's synthesizing all that information to formulate a response.
You mentioned Google's Gemini Live as an example of this real-time interaction quality.
Yeah, they've focused heavily on reducing audio latency and improving conversational flow, and the result is a much more human-like conversational quality, complete with emotional nuance recognition. We are moving toward seamless, natural interaction across all media types.
Which makes the agents far more effective in complex human-facing roles.
It does.
And finally, the physical foundation, hardware innovation. Why are specialized chips like GPUs and TPUs so critical to this rapid advance?
Well, traditional CPUs are designed for sequential processing, handling tasks one after the other. AI, however, relies overwhelmingly on complex matrix multiplication and linear algebra, massive parallel calculations.
Right.
And this is what GPUs, or graphics processing units, and TPUs, tensor processing units, excel at. They can handle hundreds of thousands of calculations simultaneously.
So these specialized chips are what allow these massive multi-trillion parameter models to operate fast enough to be useful in real time.
Exactly. They enable the scalability and speed required for the huge training sets and the instantaneous inference needed for agentic applications. And now this innovation is pushing into edge hardware.
Smaller, specialized processors that are deployed right at the point of action.
Right. Think of a custom model running on a small device in a retail store, analyzing inventory flow in real time, or a device on a harvester, analyzing crop health on the fly. This deployment flexibility is what makes agentic AI truly scalable for real-world, time-sensitive applications.
We've established the transformative power, the accelerating market adoption, and yet this immense growth introduces a severe paradox, the great AI divide. The benefits are currently concentrated, creating this widening gulf between the technology giants and, well, everyone else.
It's the critical issue facing the global economy right now. The vast majority of organizations, especially small and medium-sized businesses, are struggling to translate the potential of AI into practical reality.
And while large corporations are adopting at a rapid pace, smaller firms, those with fewer than 100 employees, they're the ones most likely to be stuck on the sidelines.
And the primary barrier isn't a lack of interest, but a lack of capacity.
Both financial and human resources.
The financial gap is stark. While the potential ROI is clear, we're talking up to 10% revenue growth or maybe $70,000 in annual savings. Many SMBs allocate only modest annual technology budgets.
I saw a note in the sources that some smaller firms genuinely struggle with the cost of even a single AI seat, even if it's priced as low as, what, $30 a month?
That's right, because those costs accumulate so quickly when you try to scale them across an organization that's already spread thin.
It really illustrates how technology, even with its potential to democratize access, can often exacerbate existing financial disparities. It makes the entry barrier for advanced custom solutions just too high for many.
And compounding that financial hurdle is the vast data gap, what we often call the proprietary data moat. This is the ultimate competitive advantage for large enterprises.
Can you paint a clearer picture of what that moat looks like for, say, a Fortune 500 company versus a small firm?
Sure. A large enterprise has years, maybe decades, of centrally managed, labeled, high-quality data, We're talking millions of structured CRM records, verified customer interactions, transcribed call center logs, meticulously cataloged inventory movements.
It's the perfect fuel.
The perfect fuel for training those hyper-personalized custom models we talked about.
And the small business reality.
The small firm often operates in what we call spreadsheet hell.
Right.
Their proprietary information is scattered across disparate software platforms, siloed local hard drives, 10 years of unsorted email threads, and basic accounting systems. They just haven't invested in the infrastructure needed to centralize and label that data.
So while the enterprise can train an AI that intimately knows its customer base, the small firm is limited to generic, externally trained models that can only handle basic administrative tasks.
That's the perfect analogy. The large firm has a rich, refined oil field, and the small firm has crude scattered across a few puddles. The resource disparity limits their ability to build high-quality custom models.
And that leads directly to strategic and knowledge hurdles. There's this severe disconnect between what leadership believes and what they actually do.
The paradox of strategy.
Exactly. 81% of business leaders are confident AI will help them achieve their objectives, but only 27% report that AI is a frequent topic in formal, company-wide strategic discussions.
High confidence, low commitment. And that gap stems from a fundamental lack of understanding. A staggering 51% of business leaders admit they do not fully understand how AI works or how it specifically fits into their unique operational needs.
For small businesses, this deficit is even more critical. 77% cite insufficient knowledge or uncertainty about AI benefits as their primary adoption barrier.
And if leadership doesn't understand the mechanisms of ROI, they can't justify the investment, which just perpetuates the divide.
And this lack of strategic grounding is why so many initial implementation efforts fail. They start small, which is good, but without a clear, measurable organizational goal, those one-off pilots just die on the vine.
Yeah.
We identified two specific implementation pitfalls that doom these efforts. The first is the problem value misfit.
This is implementing cool technology just for the sake of checking a box.
Right.
Without first identifying a clear, measurable, and expensive business problem that needs solving. You might automate a task that takes an employee 5 minutes a day, yielding negligible ROI, rather than tackling a complex, multi-day bottleneck.
You solve a $5 problem with $50,000 worth of tech.
Precisely. And the second pitfall is poor documentation and a lack of vision.
No strategic vision means the pilot has no logical next step to scale. And critically, you have poor baseline documentation.
Which means if you can't rigorously document the current cost, the time, and the error rate before you implement something, you cannot possibly prove the ROI afterward. You end up relying on feelings of improvement, which is useless when you're trying to secure more funding.
This just highlights that implementation is a strategic and organizational challenge, not a purely technical one. And finally, there's the severe workforce and training disconnect.
Employee familiarity with AI is rapidly increasing. Up to 59% of professionals say they're familiar, but this is largely a self-taught surge. Over half of the workforce, 52%, have not received any formal training from their employers.
So employees are trying to keep up on their own time, but the organization is failing to provide the standardized tools and knowledge.
That's the organizational irony. Executives themselves feel the pace is too fast. 78% feel AI is advancing too quickly for their organization's training efforts to keep up.
Which results in 55% of U.S. hiring managers admitting their company just lacks the resources or training for effective AI use.
And this vacuum often leads to what we call shadow AI.
Employees using consumer-grade, sometimes unsecure external tools because the enterprise solutions are slow, restrictive, or just frustrating.
Exactly. The human capacity to use AI is ready, but the institutional structure is lagging, and this resistance is compounded by genuine employee skepticism. Nearly 2/3 of job seekers worry AI could limit their opportunities, and nearly half fear outright job elimination.
So if employees see the technology as a threat to their livelihood, they'll actively resist adoption, no matter what the potential efficiency gains are.
It's a fundamental challenge of change management. We've covered the incredible acceleration and this widening divide, and the speed of adoption, particularly with Gen AI reaching 300 million weekly users faster than the internet reached that number. It forces us to confront a core organizational dilemma: speed versus safety.
The pace of innovation means that governance and risk mitigation can't be an afterthought, can they? They have to be foundational, especially given the documented failure rate.
The data is a stark warning. More than half of companies using AI experienced at least one negative incident.
At least one.
And the most common consequence, reported by 51% of respondents, was inaccurate or biased results. This means you have to put visible, organizational safeguards in place to maintain internal trust.
And employee trust is the key to scaling AI beyond a small pilot. If workers don't trust the output, they simply won't use the tool. What specific safeguards did our sources identify as the foundational control stack that the workforce requires?
There are 3 critical requirements identified by employees. First, about 39% require human approval before the AI makes any definitive production-level changes.
That they need to know they retain oversight.
Exactly.
Yeah.
Second, almost 35% demand strong, visible data governance and security protocols. They need assurance their proprietary data is protected and used correctly.
And the third requirement speaks directly to the agentic nature of these new systems.
Yes, 34% need the ability to roll back or undo AI actions. If an autonomous agent makes a major error, the organization must have a kill switch or a clear path to instantly revert the system to a pre-error state.
So these 3 things, human approval, data security, and a rollback function, they're not optional features. They're foundational requirements for scaling AI successfully into critical workflows.
They are, and this necessitates formalizing responsible AI frameworks immediately.
What are organizations prioritizing for 2026?
The focus is on establishing C-suite level AI councils dedicated bodies to oversee ethics, fairness, compliance, and data handling. Risk mitigation has to become continuous.
Meaning what?
Meaning rigorous testing of models before deployment and continuous monitoring of production outputs to catch drift or bias, alongside setting up those critical controls and kill switches to intervene if the system misbehaves.
But there's a significant disparity in what leaders are actually measuring. While governance is a priority, the benchmarks show this hyper-focus on speed and performance, dangerously downplaying the compliance risks.
That gap is a ticking time bomb. Of the 39% of C-suite leaders who use formal benchmarks, they overwhelmingly prioritize performance accuracy and speed and operational metrics like scalability. Those 2 categories account for over 75% of benchmarking importance.
And ethical and compliance concerns, fairness, bias, transparency, privacy, that only accounts for about 17% of benchmarking importance.
That massive skew indicates a potential failure to internalize the risks. The desire for speed is overshadowing the necessity for safety, which is especially dangerous as AI moves into the autonomous agentic space.
Right. If a model is 50% faster but 20% less fair, most companies are currently optimizing for speed.
And that could lead to costly or reputation-damaging outcomes down the line.
This brings us to a specific case study our sources highlighted, a powerful illustration of why risk mitigation is non-negotiable, particularly when you're dealing with proprietary intellectual property. Why will using generic AI models fundamentally destroy your IP strategy?
Because IP patents, trade secrets, invention ideas is the future competitive backbone of any technical organization. And using generic, broad, internet-trained AI for technical tasks like patent analysis introduces 5 severe, specific risks that no company can afford.
Okay, let's start with the most intuitive one, the security nightmare.
If you upload an invention idea, a new formula, or a proprietary design schematic into a public generic AI model and ask it to analyze prior art, you are effectively revealing your entire R&D strategy to an external, uncontrolled system.
Right.
The World Intellectual Property Organization, WIPO, is very clear on this. If you wouldn't type your invention into a public Google search, you should not feed it into a generic public AI tool.
Because the prompts and the proprietary data you input can be stored, refined, or potentially accessed by malicious actors or even the model developers themselves. You lose control of your most valuable asset.
Exactly. The input becomes part of the uncontrolled training corpus, or it's vulnerable in transit. It's a fundamental security failure. The second risk relates to reliability, randomness versus consistency.
Patent analysis demands consistent, verifiable results. You need legal certainty about prior art and potential infringement.
But generic AI, which is trained broadly and optimized for natural language fluency, generates outputs that often vary widely between users, even for the same query. It provides randomness dressed up in natural language,
Which is useless for legal due diligence.
completely unusable. You need domain-specific, custom models trained for legal consistency.
Okay, the third risk is global and highly technical. The translation trap.
Patents are global assets. They're filed in Chinese, Japanese, Korean, German, dozens of other languages. Generic AI struggles intensely with highly specialized technical legal language where one word can change the entire meaning of a claim.
Do we have an example of that?
We do. We have documented cases where generic systems trying to translate specialized Chinese patent language mistook technical components like converters for common objects like flower baskets.
That is a critical mistranslation. It creates a massive blind spot, leading a company to mistakenly believe a technology is open for innovation when, in reality, a competitor has a fully protected patent in another country.
It creates a massive, expensive legal risk. The fourth risk is the completeness problem. Generic tools may only access a fraction of the world's patent data, maybe 80 or 90% of global filings.
But in IP, 90% coverage is fundamentally inadequate.
It is lethal. Missing even a single critical competitor filing or a crucial licensing opportunity renders the analysis incomplete and dangerous. Companies have to verify that their AI systems rely on properly licensed, verified, and complete global patent datasets, which general-purpose models just can't guarantee.
And finally, the complex legal issue of blurred ownership.
Generative AI creates significant uncertainty around IP rights. Many jurisdictions worldwide will not grant copyright or patent protection for works created solely by an AI. They require clear human authorship.
So if a business uses a generic tool to create marketing copy, design assets, or even parts of an invention,
they risk creating outputs that are legally unprotectable or, worse, inadvertently infringing on the original copyright of the model's training data. This destroys the premise of their IP strategy before it even begins.
The collective lesson from these 5 risks is a powerful argument for the customization principle. For high-stakes, proprietary functions, generic, publicly accessible AI is an existential threat. The data is clear. The technology is accelerating, but strategic, mature adoption is lagging significantly, especially for those smaller firms struggling with the AI divide. So how do businesses bridge this gap and move toward what McKinsey defines as AI maturity?
Well, AI maturity is the state where AI is fully integrated into core workflows and is reliably driving substantial business outcomes.
And right now, almost no one is there.
Right now, only a minuscule 1% of leaders describe their companies as mature. The vast majority are still in the emerging or developing phase, often characterized by those isolated, non-scalable pilots we talked about.
It seems the distinction between a high performer and an average company isn't just about using AI, but how they use it.
Absolutely. The high performers, those consistently seeing a 5% or more positive impact on their earnings from AI, are qualitatively different. They are more than 3 times more likely to redesign entire workflows to maximize the AI's impact.
So they're not just tweaking.
No, they set objectives centered on growth and innovation, not just incremental efficiency tweaks. They ask, how can AI enable a new business line? Not just, how can AI save us 5 minutes a day?
That distinction transformation versus incremental tweak is crucial. So let's focus on actionable steps, particularly for the smaller businesses who are feeling that capacity gap. AI can be a great equalizer, but only with a disciplined, strategic approach.
And their key advantage is agility. Simpler decision-making structures. They don't have the bureaucracy of a Fortune 500 company. So the first step is to be highly disciplined. Start small, prove ROI.
Meaning launch targeted pilots tied directly to existing measurable KPIs rather than broad, expensive experiments.
Exactly. Focus on a single metric. Lead conversion, customer service resolution time, or inventory error rates. The sources suggest that if it's done correctly, these focused pilots should show clear ROI, meaning the cost is less than the value generated within 3 to 6 months.
And if it fails,
you kill it quickly and you learn from it.
That ties directly into the second vital step. Focus on rigorous problem definition. Don't just chase the shiny new software.
You have to define the cost and the error rate you were trying to solve. You shouldn't aim for vague, improved productivity. You should aim to reduce invoice processing time from 2 hours to 30 minutes, or reduce the data entry error rate from 7% to 1%.
And documenting that current baseline, the cost, the time, the error rate, is what allows you to prove ROI later and escape that poor baseline documentation pitfall.
It is.
This strategic approach is also the key to moving beyond shadow AI to what you call strategic AI.
Mm-hmm.
The third step addresses that knowledge deficit we identified in leadership.
Investment in literacy first is paramount. Before you buy the software, you must understand the technology's capabilities and its limitations. This is essential for the 51% of leaders who admitted they don't fully grasp AI. It's an investment in human capital that yields higher returns than a rushed software purchase that just sits unused.
And this is where external support can be a massive leveler for SMBs. We saw examples of governments stepping in to bridge that knowledge and financial gap.
The Singapore IMDA Generative AI grant is an excellent global model. This initiative offers targeted financial aid and expert guidance specifically for non-ICT businesses, retail, healthcare, logistics, manufacturing, which often lack internal technical teams.
It dramatically lowers the barrier to entry.
It does. It helps them move past capacity constraints and focus on transforming their core business processes responsibly.
And such external support proves that policy can effectively level the playing field, ensuring that the AI divide doesn't become a permanent, entrenched competitive imbalance.
Finally, we have to return to workforce readiness. Leaders must prioritize formal training because the employees are willing. Nearly half, 48%, are actively requesting it.
And we noted the crucial role of millennial managers as internal change champions.
They are the evangelists. 2/3 of these managers are fielding questions about AI tools weekly and actively recommending successful, vetted tools to their teams. Recognizing and supporting these internal champions is critical for spreading adoption organization-wide.
And the training must be specific, not generic.
Absolutely. Training needs to be tailored to the role. Technical teams require intensive boot camps on model fine-tuning and library creation, while functional teams, marketing, HR, sales, need focused classes on effective prompt engineering and using agentic systems responsibly.
And we're seeing major coordinated efforts globally on this.
We are. Like the UK's plan to upskill 7.5 million workers by 2030 through partnerships with major industry players like Accenture, Amazon, Google, and Microsoft.
That commitment shows that closing the skills gap is not just a corporate initiative, it's a national economic mandate.
It requires industry-government coordination. The people who use the tools must be at the heart of the strategic transformation.
This has been an incredibly detailed look at the AI landscape, from the measurable, specific ROI of custom solutions to the stark reality of the great AI divide and, the necessary leap into agentic autonomy.
Let's quickly summarize the 3 strategic takeaways that should guide every listener's actions moving forward.
Okay, first, customization is the non-negotiable differentiator. Generic AI will lead to incremental gains. Tailored solutions, powered by proprietary data, deliver massive, measurable ROI.
Right. We saw that in the 40% reduction in unplanned downtime in manufacturing and the 19% reduction in loan defaults in financial services.
Second, the Great Divide is real. It's driven by a trifecta of budget constraints, data scarcity, and skills gaps. But it is addressable.
And SMBs have to bridge this gap not through reckless spending, but through hyper-focused strategic implementation, starting small, rigorously documenting ROI, and prioritizing investment in human literacy before software.
And third, the shift toward agentic AI and superagency is accelerating the competitive timeline. This technological leap mandates robust, continuous governance.
Things like human-in-the-loop processes, strong data security, and the ability to roll back actions are absolutely non-negotiable for critical functions, especially to safeguard proprietary IP, which is instantly threatened by generic public models.
And that leads us to our final provocative thought, shifting our focus from the software to the foundational infrastructure.
The AI revolution is poised to accelerate economic growth globally. Estimates are placing its contribution to U.S. GDP growth as high as 1.5%, a non-inflationary burst of productivity.
But this immense computational power, fueled by specialized hardware and massive new data centers, it requires an equally staggering demand for electricity. The capital expenditures by hyperscalers for this infrastructure are forecast to hit over $325 billion.
And this is why the quote, "electricity is the new oil," has gained such resonance in financial circles. The generative demand for power sparked by AI is already driving up the stock prices of utilities and could very quickly lead to political resistance.
Potentially targeting AI for spurring higher energy costs for consumers and businesses alike.
Exactly.
So if AI is the new oil fueling this unprecedented productivity, how will you ensure your business and society manages the political and infrastructural cost of that energy demand? That's the complex question of scalability, sustainability, and policy that defines the next decade of the AI revolution.
A profound challenge that moves the AI discussion beyond the chip and into the power grid.
Thank you for joining us for the deep dive. We'll be back next time with more of the critical insights you need to stay ahead of the curves.